You are listening to the Information Security and OSINT podcast, episode 16, originally released on June 17th, 2020. My name's Josh Amishav. This week we have Ty Miller on the show. Ty is the Managing Director of Threat Intelligence. He also runs the Shellcode and Security Automation training courses at Black Hat. Ty is on the Black Hat Asia Review Board as well as the Board of Directors of Crest ANZ. Crest is a Australian InfoSec accreditation company. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. What's the easiest way hackers break into your network? By using valid usernames and passwords. Attackers collect millions of leaked credentials from almost daily data breaches. Without visibility into which of your employees or users' credentials have been leaked, it's tough to protect against this. Integrate BreachSense's powerful and easy-to-use API into existing security solutions to prevent account takeover and stop online fraud. Ty, welcome to the show.
Thank you very much.
Let's start with who you are and what do you do?
Sure thing. So, as you say, I'm the Managing Director of Threat Intelligence. So we're a specialist security company based in Australia. And ultimately we just pull together some of the top talent, not just in Australia, but from around the world, and we have a pretty strong penetration testing background, but have a big vision for the company, which is building out the world's first security automation cloud called Evolve.
Okay, and how did you get your start in hacking?
So pretty much started. I've been in the industry about 20 years, and basically started my whole career in security as the security officer for a university in Sydney. And back then, there was no firewalls, there was no data centers, anything like that. Basically, just thousands of systems with public IP addresses sitting on the internet, and no budget for security. So basically, taught myself how to hack to break the uni systems as the security officer, because I was allowed to, and basically prove how bad we were to get budget to go and fix it. So we did that, and got multi-million-dollar budget to go and build the first data center and start securing the uni. And around that time, there was some of the first startups, penetration testing startups in Australia, who I then joined and became the CTO of, and been hacking ever since.
So at some point you got on the review board of Black Hat. Let's back up a bit. How did you get involved with Black Hat?
Yeah, so look, early on, because there was no training in Australia back then for penetration testing, and there was very few companies who actually did it. So I had the opportunity back then to sort of go to Black Hat very relatively early on, compared to a lot of the industry these days, and started seeing some of the talks and things there, and some of them were fantastic, and some of them I sat there thinking that I could do a better job than this guy. So I set myself the task to come up with a concept and develop it and present it Black Hat the following year. So I did that, and submitted my first talk to Black Hat, which was back in 2008. And that was the reverse DNS tunneling shellcode, which I developed back then because it wasn't around back then. Things have come a long way. Back then there really wasn't many sort of easy to access sort of shellcoding resources. There was a lot of focus on sort of exploitation and things, but so I sort of pulled that together and made a lot of tutorials and things public, and went and presented that at Black Hat back then.
At that point, were you able to use Metasploit to generate shellcode for exploits?
Yeah, you could. They were still relatively simplistic compared to what we've got today. So, okay. You had things like your bind and your TCP payloads. The only really tunneling payload was the HTTP tunneling shellcode that they had in Metasploit, but it was really limited back then, so it really didn't work in a lot of situations because it required Internet Explorer 6. sort of showing the age on that one. So IE6 had to be, configured with proxy and authentication to be able to go through the proxy and those sort of things. So if you sort of didn't have all of those lined up, then basically, your tunneling shellcode would fail. So one of the reasons why I came up with the DNS tunneling was because back then, basically no one had, things like split horizon DNS set up, and basically it was a really good way to get out of an organization from a tunneling perspective. There was no like authentication required. You could use the built-in configured DNS for the workstation that you were compromising. And it really sort of increased the exploitation success rate of the exploits that I was using for client-side attacks.
So when you do pen test today, how common is it to see? Can you still use the DNS split tunneling technique to tunnel out a connection, or is that a solved problem?
Yeah, no, you can still use it today, absolutely. So a couple of years after that presentation, I started up the shellcode lab at Black Hat, and that was 10 years ago. And we've been running that ever since at Black Hat. And during that first training course, I got approached. Well, I had some visitors come, and that was the guys from Core Security, and they came in and got me to said that they were interested in getting me to implement the DNS tunneling shellcode into Core Impact. So over the course of the next year, basically worked with that team and integrated the DNS tunneling shellcode into Core Impact as well. So as far as I'm aware, that's still in there, and you can use it as part of the tunneling. And that was a much, I basically wrote it from scratch because the one that I presented back in 2008 was definitely not streamlined, whereas this one was actually by far the smallest shellcode that they had in Core Impact, which means that you can get it into more exploits, which means you can break in more systems.
Cool. Okay. Now you also run another course, right? You run on automation.
Yeah.
Okay. So
that was originally called the Security Automation Lab, and that's since got changed to be automating security. What is it? I'll have to look it up. automating and orchestrating security with open source. So it was really just a name change, same course, but name change was just to really make it clear to students that it was using open source tools because they basically don't want any commercial stuff in some of these Black Hat courses. So it's really just to emphasize that. But ultimately, that course is designed to teach students how to integrate security automation into their organizations using open source tools, and also expanding their horizons around sort of how they think, what areas of security they think they can actually automate. A lot of people and a lot of the students that we actually had on the course, were coming to the class and thinking, depending upon their background, a lot of them came from sort of the application security side of things, and so they saw sort of things like your traditional DevOps pipelines for application security as the area that that was the only area to do security automation.
Meaning which processes in particular?
So things like into like doing either automated code reviews or application security scanning when you're committing application code to Git repo, and then having that trigger some of the automated security tests against your application code before it goes through to a staging or a production environment. Whereas, and then you get another class of people who only think of it from an incident response perspective. But as you would know, there's a whole range of different areas that you can do with security automation, and whether it's automated these days, automated penetration testing, automated incident response, orchestrating security infrastructure, automating cyber threat intelligence, and automating things like compromised account monitoring and integrating that into your different systems. So it helps to teach people how to do that with open source. So if they do have security budget limitations, there's an open source option for them. The flip side of that is that the open source options basically have to get built almost from scratch for you to a point, depending upon what you're trying to automate, which means that there's a much higher operational overhead of actually, getting it in place as compared to, getting a commercial security automation solution.
Okay, so let's I want to further understand how much work is actually involved. If I want to go down the open source route, let's say you mentioned a couple different options there. Let's say if we're doing the incident response or the pen testing route. So what tools would I use? How much work is actually involved? What would the process look like?
Okay, so at the end of the day, it depends on how deep and how accurate you want to go. It is an ongoing investment in your time to actually do this. So if you think about penetration testing, for example, all of the different tools that a penetration tester would use, from everything from your reconnaissance to fingerprinting and scanning, your attack and exploitation, your post-exploitation, lateral movement, and then also reporting or integrating into, even ticketing systems and things. There's a huge amount of tools there. They're all completely different qualities, and you also then have to manage things like stability and quality of the output, so things like false positives and those sort of things. So if you think about that from a penetration testing perspective, there's a huge amount of effort to chain those together and get an end result that's similar quality to what you would expect from a penetration test. So you can automate that, and we show you how to do some of it from an open source perspective. If you just want to do a cut down version, and you just want to do vulnerability scanning, for example, that's much easier, right? But it's not a penetration test. That becomes much easier. You can use things like OpenVAS, or you can use your commercial vulnerability scanners and integrate with APIs and things. But all of that basically has to get developed. And there's typically SDKs that you can use to write wrappers and stuff like that. But ultimately, you pretty much have to do all of that yourself. So that's huge when you start looking at things like automating your penetration testing or your vulnerability scanning, and then you look at doing that for your DevOps pipelines, and then you look at doing that for your incident response, collecting evidence, analyzing and responding to it. Doing that for a whole range of operating system versions and making sure that's stable, because you come up with different tweaks, whether it's, for a Windows 2003 box versus a Windows 2019 box, they're very different commands, different executables you need to use to do things like dumping memory. So it definitely, from a skills and a time perspective, it definitely needs a lot of long-term dedication to building up those capabilities. And ultimately, what I say in my course is that if that's where you're at, where you don't have the budget to buy commercial tools, then this is what you need to look at, utilizing open source tools, but you've got to spend the time to actually do it. And you basically just build it up piece by piece over time. So whatever's a priority for you, you build it up, you've got that capability, and then you move on to the next one.
Cool. Okay. Are there things that can't be automated well that you recommend this will always be a manual process?
Yeah. So, another good example again is things like penetration testing. So, we specifically draw a line at one point where, we'll go out, and so within our Evolve platform, we'll go out and do things like, identify all the vulnerabilities, automatically identify the exploits. Any Metasploit exploits that we find, will automatically configure those and exploit systems and do post-exploitation, all those sort of fun things. But where we draw the line is from that trust perspective of where some of those exploits are coming from. So we'll identify things like, exploits in ExploitDB or GitHub and as well as some of the commercial exploit frameworks. But, we're not going to go and grab one of those, an exploit from ExploitDB and go and run it against your system because it might delete your hard drive. So that's where we tend to draw the line from a automation perspective for pen testing, is that trust level. And that's where, security specialists then, you can automate the pen testing up to a point, which really we internally use that to set the baseline quality of our penetration tests. And then we've got our specialist guys who then go on top of that, analyze the results, but also then say, right, well, we found a bunch of exploits in ExploitDB or in GitHub or wherever it is, and go and analyze those exploits. So, Evolve will go out and find, the exploits, whether in ExploitDB or GitHub, for example, but we're not going to automate that. So we get our guys to then go and analyze those exploits.
Oh, hold on 1 second. You mentioned Evolve. What is Evolve?
So Evolve's our platform, which is the world's first security automation cloud. And ultimately, if you think about things like AWS and Azure from an infrastructure cloud perspective, Evolve is a global cloud dedicated to security automation. So just like you would with AWS and Azure, if you sign up, you get an empty account. And then you can go to the Evolve marketplace where we've got what we call on-demand specialist security capabilities. So the problems that we see in the industry, and we have seen for a long time, is the lack of skills, resources, and budgets. And that's going to become even more the case with, the global economic sort of crisis that's going on. So, the fact that people don't have the deep technical skills within organizations or even in managed security providers to do a lot of the security, whether it's pen testing or incident response, they don't have those deep technical skills, because generally you've got within organizations and even MSSPs, they've got generalist security people because they need to, which is fine, but they need to span more than just one part of security. They have to cover the whole organization, right? So because you've then got limited security budgets, it means you have small security teams, which means that those people have to cover a wide range of security and not necessarily the deep technical parts of it. So what Evolve does is provides those deep security capabilities on demand. So you can go to the Evolve marketplace and say, hey, my team now needs to do internal penetration testing, but we don't have that capability. So you go to the Evolve marketplace and you import that capability into your account. You've now got the ability for your team to then run internal penetration testing and have it scheduled every month, for example. And you can do that across, your corporate networks or your data centers or your AWS or your Azure environments. You might then say, right, we've had a security breach, or we just want to enhance our incident response ability. So you go to the marketplace and say, all right, I want to import, automated incident response capability. And that imports into your account. Now your team has the ability to just say, go and collect evidence from that machine, analyze it, and you can even respond to it. So because Evolve is a cloud, it's all API driven, which means that there's a command line interface to the whole platform, as well as a Python SDK, which means you can write very easy wrappers to integrate with things like, SIEM solutions, for example. So you could set up, for argument's sake, a team, let's say Splunk, for example, and say, right, if this type of event, let's say a workstation's been breached with some malware, and that event comes through to your SIEM, you can have that configured to say, go and run the command line interface to Evolve to kick off, automated incident response on that machine to collect the evidence, analyze it, automatically get the indicators of compromise, put that into a Yarrow file, and then search the entire environment for other machines that might have been breached and automatically contain them. or whether it's so we've got it. I don't know if you know, but at the moment, Australia is getting absolutely hammered with attacks and security breaches. So we're doing a lot of incident response work at the moment where some of these major cyber attacks are really impacting companies. So, we're able to utilize Evolve to be able to do at scale sort of evidence collection and analysis and those sort of things. So, as well as things like, some of these companies just pretty much all of the companies don't have proper log retention and those sort of things. So, just being able to say to Evolve, go and orchestrate a scalable syslog collector and just start saving out the data so it doesn't get lost, or scale up a SIEM solution and start sending events in so that we can monitor some of the activity on the internal network.
Cool. Okay. What percentage would you say, when like you have your security team, they're running the automated tools, what percentage are you covering let's say in a forensic investigation? What percentage can you cover using automated you're using Evolve or automated tools as opposed to what needs to be done manually
for an incident response engagement?
Yes, for example.
Yeah. So it really depends upon the breach. If it's one machine, you can cover a pretty good percentage of it, because ultimately you go and collect the evidence, it gets analyzed, and you respond to it.
The analysis done automatically, like if you have a team that doesn't have the skills and then they import the incident response module, but they don't have the skills, what do they need to, like, they get the raw data? Is Evolve analyzing it and then just giving answers, or what skill set do they need then?
Yeah. No, so nothing, and that's the whole point of the platform, is that Evolve will automatically go and collect the evidence. It'll then analyze it and automatically create the indicators of compromise for you for that attack. And then it can even feed through to things like Yarrow scans, or it integrates with Slack as well. So it can say, hey, this machine just got breached. We collected the evidence, we analyzed it, and it's been confirmed. Do you want to shut it down, for example? And you say yes, and it'll go and shut it down for you. But then when you start looking at some of these larger scale incidents where, it really depends on the type of attack that's happened as well. But, it's much more helpful to be able to, from a specialist security team who, in those incidents where there are major breaches, you typically go and get, a specialist team in to come and help manage it. Being able to just say, hey, across the entire environment, go and collect, all of the memory running processes, network connections, your registry hives, your logs, your, user accounts, your drivers, all that sort of stuff, and just pull it out from all of the machines and have it collected automatically is a huge time saver. So just even collecting that evidence is massive. For those types of engagements, we tend to also orchestrate the SIEM solution and automate the deployment of things like EDR agents across the environment, so we can also track the attacks from a central SIEM solution as well. So all of that just really cuts down on the manual effort to speed up the time to respond. So it's hard to say sort of the percentage, coming back to your question, but
I don't think there's a huge time saving though.
Yeah, it's huge. I mean, like in the couple of years ago when we did the first round of the security automation training at Black Hat. So we ran a couple of training courses over in Black Hat USA and one in Black Hat Europe. And so across those courses, there was about 120 students. And as we got to the automated incident response part of the course, I got everyone to say, put their hand up. And I said, all right, if you don't, put your hand up if you have an incident response procedure for your company. and only about half of them put their hand up for that to begin with. I then said, all right, keep your hand up if you actually have an incident response team who know what to do with that. And half of them put their hand down, right? And then you say, all right, how many of you would know how to go and, how many of you know what evidence to collect off machines? A lot of them put their hand down on that point. So, and these are security specialists, right? These are black hat students. These aren't just, random people. They're supposed to know this sort of stuff. So then we're left with a pretty small percentage of people, even early on, in terms of what evidence do we need to collect off a machine. And then said, keep your hand up if you know how to go and collect that evidence off the machine. At that point, from across about 120 people, I think I had about 3 left with their hands up. I then said, how many of you know how to go and analyze that evidence to identify malicious activity, things like, analyzing a memory dump. There was one guy left with his hand up and I said, do you know how to, extract and define the indicators of compromise and contain the breach and search the rest of your environment to see if those indicators exist? And he said no. So not a single person out of 120 black hat students actually knew how to do an end-to-end incident response investigation. And that's just demonstrates the state of the industry, where, they don't have these capabilities, and it's getting harder and harder and harder to stay on top of all of this stuff with more technologies going out there. They say the attacks are more sophisticated, but, that's arguable because I just don't think that the attackers need to be more sophisticated. One of the national cyber attacks going on against Australia at the moment used all open source tools and managed to break into a whole bunch of stuff. They're already known vulnerabilities. They even use the proof of concept backdoors. So, it's almost like they were trying to get caught and still managed to break into a lot of places.
Okay, let me ask you, if let's focus on a pen testing module. For somebody who doesn't have the budget, if you were to use the 80-20 rule, what open source tools would you recommend that somebody could use to be able to get 80% of the benefit by using these tools?
By using open source tools?
Open source tools. Which open source tools would you recommend that would give people a lot of benefit with the least amount of effort?
Yeah. Look, there's, when you're looking at penetration testing, a lot of people, you tend to think of vulnerability scanners, right? When you're looking at an initial tool set. So really from an infrastructure perspective, the only real open source vulnerability scanner out there is OpenVAS. There's a couple of other sort of, things that might be specifically focused on, for example, like Linux or something like that. You've also got the Nmap NSE engine as well, which you can look at, but ultimately that's where you're looking. The downside to OpenVAS is that there's a lot of false positives that come out of it, so you need to manage those, which isn't too hard. You can start excluding plugins and those sort of things if they're throwing out too many issues. The other side, from a web perspective, you'd be looking at things like Zap. Ultimately that's been designed to be, it's got an API that you can hook into and automate a bunch of that application security scanning. So I think they're probably 2 really good ones. The other side,
are you following Google's Tsunami project? Familiar with that? They just released. I don't think it has the modules yet, but it looks like that they want to have a vuln scanner to do things like OpenVAS.
Yeah, that's good. I haven't personally. My guys might have, but look, there's a lot of really good tools that are coming out. It just depends on the maturity. There's a bunch of interesting web scanners that have come out as well. Typically web scanners aren't by default aren't fantastic from an automation perspective, typically because web apps are all custom built, so they're all different. Whereas infrastructure is a little bit more predictable. You find an SSH port, you basically know what attacks that you can do against it. Whereas when it comes to web, it's all custom developed, applications and those sort of things. So it gets a bit harder, especially once you get into the authenticated side of things.
Have you used that? You mentioned Zap before. Have you used that? I know you're I think you're a Burp user. How does can you offer an insight in Zap compared to Burp in terms of the results?
Yeah, look, I can't go past Burp. I mean, it's a very good product. I mean, I remember years and years ago we used to use Web Inspect, and Burp didn't have its scanner in it back then, and then it introduced it, and it got better and better and better, and Web Inspect got sold off, and it started to get less accurate, and eventually, we were paying a lot of money for Web Inspect, and Burp ended up finding more, and it was more accurate, and that's gotten better and better as the years have gone on. Zap, back then was, when the only scanners around, even, especially before Burp came out. And it seemed to get worse for a while there. But I think over the last sort of probably 5 years, there's been a lot of improvements in Zap, and it's really come up against Burp in a pretty good way. I think Burp still takes the lead, but Zap's definitely, from an open source perspective, Zap's definitely come a long way.
Have you ever used W3AF?
Yeah, not for a while. I mean, I've moved into an MD position, so rather than hands-on stuff, but I know that some of my guys use W3AF.
Okay, cool.
For the scripting side of things.
Ty, if people want to get in touch with you, what's the best way to reach you?
So you can get me on ty.miller@threatintelligence.com. If anyone's interested in Evolve, they can go to evolve.threatintelligence.com and register your own account.
Perfect. All right. Thanks, Ty. That's it for today. If you have any feedback or questions, please contact me at podcast@breachsense.io. And if you got value from this episode, then please share it with a friend. See y'all next week.